Hello everyone, welcome to the video tutorial series of the operating system. I am your instructor Varshada. Welcomes you all to the video tutorial series. Let's start today's lecture. So, topics to be covered in this lecture. We will see the banker's algorithm today, okay, in which we will see the data structure of the banker's algorithm. Then we will see the safety algorithm and resource request algorithm. That is the part of the banker's algorithm. And then we will see the characteristics of the banker's algorithm and then disadvantage of the banker's algorithm. Okay, so let's start our lecture. So first of all, banker's algorithm. Okay, the resource allocation graph. We all are aware about this RAG, that is resource allocation graph algorithm, is not applicable to the resource allocation system with multiple instances of each resource type. But we can do this with the banker's algorithm. We can apply the banker's algorithm for the resources of the single type, as well as we can assign the bankers, we can use the banker's algorithm for the resources of the multiple types, that we will see later when we will see the examples of this. Okay, banker's algorithm is used to avoid the deadlock and allocate the resources safely to each process in the computer system. Okay, so why banker's algorithm is used? It is used to avoid the deadlock. Okay, and it is used to allocate the resources in the safe manner. Okay, what is the safe state that we have discussed in the last lecture? Now, why the name is the banker's algorithm? Okay, so the name was chosen because the algorithm could be used in the banking system to ensure that the bank never allocate the available cash in such a way that it could no longer satisfy the need of all its customers. Okay, so again, when we will demand for the loan in the banks, so at that time, the bank, what bank will do? Bank will see whatever the amount is available with the bank or not, whatever the amount this customer is demanding. Okay, so every time it will check and then it will give the loan according to the customer's demand. So that's why this algorithm is known as the banker's algorithm. So every time we will see if the resources is available, and if the resources that the process is demanding that will not lead to the deadlock, then we will satisfy the resource, then we will satisfy the demand of that particular process. Okay, so when a new process enters in the system, it must declare the maximum numbers of the instance of each resource, the type that it may need. Okay, so in banker's algorithm, first the process, when the process is entering the system, first it has to define the maximum resources that will be acquired by that process during its execution. Now this number may not exceed the total number of resources in the system. Suppose the total number of resource is 10 and process is demanding the 12 resource, then it is not possible. Okay, when user requests a set of resources, the system must determine whether the allocation of this resource will leave the system in a safe state. Okay, so when the process demands for the maximum resource, for example 8 or 9, okay, and make sure it is not greater than the total available resources. And again, we have to define if we are granting the resource to this particular process, it should not lead to the deadlock state. Okay, it should not lead to the unsafe sequence. Then and only then we can we can fulfill the request of this particular process. If it will, the resources are allocated. Otherwise, process must wait until some other process release the enough resources. That means whatever the process is demanding this particular, whatever the resource is demanding this particular process. So if the resource is available, then immediately assign that resources to that particular process, and that total number of resources is not available, then process should have to wait. Okay, several data structures must be maintained to implement the banker's algorithm. Okay, so numbers of data structure is maintained to implement the banker's algorithm. We will see one data structure. Okay, so the data structure encode the state of the resource allocation system. What the data structure will do, how many resources are available, how many assigns, how many process wants, this all the informations we want. So that should be mentioned in the data structure. Okay, now when working with the banker's algorithm, it requires to know about the three things, which are how much each process can request for each resource in the system. So it is denoted by the max. Okay, how much resources will be requested by the process, that is denoted by the max. Then how much each process is currently holding each resource in the system, how much resources assigned to that particular process, so that is known as the allocated resource. And how much resources available, how many resources are available, so that is denoted by the available. So it represents the number of the each resource currently available in the system, and it is denoted by the available. So you know these three things: max, allocated, and available. Max, that means maximum number of resources process wants. Allocated, that means the number of the resources that is allocated to the process. And available, that means the total number of free resources that are now available in the system. Now, in the following data structure, n is the number of the process in the system and m is the number of the resource type. So let's start the data structure of this banker's algorithm. So we just defined three things in the last slide. Just let's define it in detail. So available, that means what? A vector of the length m indexes the number of available resource of each type. So if available of j equals k. Now what is the meaning of this? If available j equals k, then k instance of resource type rj are available. Okay, if available j is equals k, that means what? K type, k number of resources are available of the resource type j. Okay, so here suppose I am writing available in bracket in place of j type drive equals 5. So now what is the meaning of this? Okay, so 5 resources of tap drive is available now. Got it? So that is known as the available. After that, max. So max is what? N cross M matrix defines the maximum demand of each and every process. Okay, so if max of ij equals k, then we can say process pi may request at most k instance of resource type rj. Okay, so max 1 tab drive equals 5. So what is the meaning of this? Process 1 may demand for the 5 resource for completion of its task. So now you got it, this available and max. Now let's see another data structure. Okay, so next is allocation and then need. Now, for what is allocation? An n cross m matrix defines the numbers of resources of each type that is currently allocated to the each process. That means if allocation ij equals k, then the process pi is currently allocated k instance of resource type rj. Okay, so suppose I am writing here allocation 1 in allocation first bracket 1 and in another brackets, suppose it is a trap drive equals 4. So what is the meaning of this? Process P1 has allocated 4 instance of the trap drive. Got it? Okay, and its maximum need is 5. So now how many resource process 1 need? 1. 5 minus 4, that is 1. 4 is allocated, 5 is a max need. So 5 minus 1 is a, 5 minus 4 is a 1. So that is what need. Got it? So n cross m matrix indicates that the remaining resources need of each process. So if need of ij equals k, then process pi may need k more instance of the resource type rj to complete its task. Got it? So how we can define it? Need of ij is equal to max of ij minus allocation of ij. So this is the formula to define the need matrix, and that we have to do when we are calculating the example of this banker's algorithm. Okay, that we will see in the example in detail. Now, the banker's algorithm consists of the two algorithms, which are the safety algorithm and resource request algorithm. Okay, so safety algorithm used to check whether or not the system is in the safe state or it follows the safe sequence in the banker's algorithm. Okay, so that is known as the safety algorithm. And another is the resource request algorithm. What it checks how the system will behave when the process makes the each type of resource request in the system as a request matrix. So let's see this. So let's start with the safety algorithm first. So these are the steps for the safety algorithm. Now in first step we are defining the two vector. Which are the two vector? Work and finish. Work, that means the total available resources. So whatever the available resources is that will be assigned to the work. And finish of I is equal to false. That means right now no any other has completed its task. Okay, and second step is what? Find out the index I such that both these conditions should be true. Finish of I is equal to false, that means process is still in the execution, and need of I that is less than or equal to work. Okay, so need of I that is less than or equal to work. So that means here need of I, the suppose process I needs 3 resources and available resources are just 2. So we are not able to assign that resources to the process 2 because available resources are not that much. That's why. Now this is the safety algorithm. So these are the steps for the safety algorithm. First, start with the first step. Here we have the two vector, that is work and finish. Okay, in work and finish, what will be the value we are storing in the work and finish? Work is equal to available resources. So total available resources will be stored in the work. Then finish of I is equal to false. That means right now no any other process have completed its task. So finish of I is equal to false. Now next is what? We have to find out the process which is still in the execution. Okay, and it is waiting for the resources. So find an index I such that this both conditions should be true. Finish of I is equal to false and need of I is less than or equal to 1. Okay, so need of I, that means need of that particular process is less than or equal to the available resources, and process is still there in the execution. Then we have to allocate the resources if the resources are the available. And if no such I exists, we just have to jump to the step number 4. Okay, and if such I is exist, that means if such process is exist, what we have to do? Work is equal to work plus allocation. Okay, if such process exists, we will assign the resources to that, and now process will complete its task and it will release the resources. So now what the available resource will be? Work is equal to work plus allocation. So suppose now the available resources are suppose 1, and process have released the 4 resources. So 1 plus 5, total 5 resources are available, and we have to set finish of I is equal to true. That means process have completes its execution. Okay, and again go to step 2. So repeat this steps, and if no any such I exists, and directly we will jump to the step 4. That means finish of I is equal to true for each and every process, and these all are the safe sequence. Got it? Now next algorithm is a resource request algorithm. This is also the part of the banker's algorithm. Okay, here step number 1, if request of I is less than or equal to the need of I, then go to step 2. Okay, so if request is less than need, then we have to move to the step 2. Otherwise raise an error. That means if the request is higher than the need, then we have to raise the error since the process has exceeded its maximum claim. So suppose process have claimed the 5 maximum need and now the process is claiming the more resources, than it is not possible. Okay, now second step, if request is less than or equal to available, then go to step 3 and otherwise the process should have to wait. Okay, so if the request is less than the available resources, then we have to move to the step 3. Otherwise, PI must wait since the resources are not available. Okay, now the third step, the system pretend to have the allocated and the requested resource to process PI by modifying the state as follows. Okay, so here available is equal to available minus request because we are granting the resources to the process. Allocation is equal to allocation plus request. Now we have to do this plus in the process allocation steps. Okay, so suppose process have the 5 allocated resources. Now it requires 2. So we are allocating 2 more resources to the process. So now allocation will become the 7. And need is equal to need minus request. Again, we have to change the need matrix also. So need is equal to need minus request. Okay, so this thing we have to do in the resource request algorithm. Got it? So we have seen the two algorithm. One is the safety algorithm and another is the resource request algorithm. Okay, so now all of you are about the banker's algorithm. So let's see the characteristics of the banker's algorithm. Okay, so these are the characteristics of the banker's algorithm. If the process demands the resource, then it has to wait. Okay, so first thing is what? If the process demands the resource, then it has to wait. If there is no available resources, banker's algorithm consists of the advanced features of the maximum resource allocation. That means we should have the prior knowledge of the maximum resources. And in the banker's algorithm, various resources are maintained that fulfill the needs of the at least one client at a time. And in this system, we have the limited resource. We don't extend the resource if the process required the much more resource. This is not possible. And in the banker's algorithm, if the process gets all the need resources, then it must to return the resources in the restricted period. It should have to complete its task and it should have to return all the resources. So these are the characteristics of the banker's algorithm. And now what are the disadvantages of the banker's algorithm? It requires a fixed numbers of the processes and no additional processes can be started in the system while executing the process. Okay, additional demand we cannot define for in the banker's algorithm. The algorithm does no longer allow the process to exchange its maximum needs while processing the task. So we cannot define the maximum needs, we cannot change the maximum needs. Each process has to know the state, each process has to know and state their maximum resource requirement in advance. So we should have the entire knowledge of the resources that the process will require in advance, and the numbers of resource requests can be granted in a finite time. So for limited time only we are granting the resources to the process. So these are the disadvantage of the banker's algorithm. Okay, so in this video, we have learned what is the banker's algorithm. We have seen the data structure of the banker's algorithm, and we have seen these two algorithms that is the part of the banker's algorithm, that is a safety algorithm and a resource request algorithm. And after that, we have seen what is the characteristics of the banker's algorithm and which are the disadvantages of the banker's algorithm. Okay, in next lecture, we will see the examples of the banker's algorithm for a single resource and for the multiple resource. Okay, so remaining interesting topic we will cover in the next lecture. Thank you for watching. We will meet in the next lecture. Thank you.